Hi, my name is Bakamu Dukanele. I'm working at B3 as a scientist who characterizes various types of materials, and I work in an X-ray testing lab. Where I work, the unit is called a Center for Material Science. We have an abbreviation which we call it CMS. And our Center for Material Science focuses in characterizing various types of materials. But where I work with commonly solids and liquids. And generally, the X-ray interacts with the material, and then we are able to characterize the elemental composition of the materials from sodium to heavy materials like lead. And then we have different types of machines that I work with, and they have their various types of testing. We have an acid tiger XRF, a WDX type of machine, which we call a wide dispersive X-ray fluorescence spectrometer. And then we have an XRD, which is an X-ray diffractometer, which characterizes the mineral composition in the materials. So as you can see behind me here, I have various types of materials. Some of those materials that I have, like you can see here, this is coal. And we have a project that deals with coal to liquid project. And that is, coal is then processed to give various types of chemicals from it. And as you can see in these sample vials here, these are the various byproducts of coal. And coal beneficiation program really covers a wide spectrum of applications. But one of the most important ones is that fuel has become a very special commodity in which it is in high demand. And as we have experienced it as a country in Botswana, we found that we are importing fuel. And this is one of the programs that can alleviate the demand for fuel. Then we have the mining sectors like the rocks. Here's one of the samples. So the sample doesn't go in as it is. We first have to prepare it by pulverizing it to powder. And then once it's powdered, we then check that it should be less than 56 microns for particle size. And then that is when it can go into the system. And behind me here is a computer then that is connected to the system, which I use to scan the data. And then I would come up with, like you can see over here, elemental composition of the material. So it means that from 100%, I will have different proportions of elements in the composition of the material that I'm looking at. And then in the XRD is a little bit different because elements combine to form crystals. And because a crystal structure is unique form on its own, it's more like it's a fingerprint, we then direct the X-rays into the mineral, and then it actually reveals the fingerprint of the mineral, which we call the XRD pattern. So I'm going to explain these two, how they work well together. For instance, if I am investigating materials, two materials, that is graphite and diamond. These two materials have got carbon composition. Then when I run it through the XRF, it will reveal the elemental composition of graphite. But I wouldn't know which is diamond and that which is graphite. But because I have known the elemental composition, I can then use that information, transfer it into the XRD, and then the XRD, because these two materials have got different crystal structures, is then revealed to me, because I know they are carbon composition materials, that these two structures are different by their patterns, and therefore I can then confirm that indeed this is graphite and that is diamond.